Hi guys, so now I'm going to teach y'all partial derivative. Okay, so now what I'm going to teach y'all is actually the definition of partial derivative and also how to apply the partial derivative over here. So I have three questions over here, 1, 2, and 3. So the first question, what I'm going to do is I'm going to solve it by using the definition of partial derivative. The second question, what I'm going to solve here, I'm going to solve like this. Okay, fyz, fsz, and the third question is I'm going to solve it like this. Okay, fsy, fz, yx. Okay, it's quite confusing, but it's fun. Okay, I'm going to teach you. Okay, so now the first question is what we're going to solve. We're going to solve it by using the definition of partial derivative. So actually the definition of partial derivative is just like the definition of derivative. Okay, by using the same formula. Okay, when we want to, okay, let's say I want to find the f as y over here. What I'm going to do is, okay, in the derivative video I did teach you f prime s is s plus h. Okay, we have f s plus h minus f s over h, right? But in the partial derivative, it's just okay. We have a limit also. We have a limit when h approaching 0. Okay, it's just the same thing. We have limit h approaching 0. We have over h as well. Okay, and then but we have different over here. Okay, if you want to differentiate in respect to x, okay, we want to differentiate respect to x, then s will plus with h y and then minus f s y. Okay, if I have here I want to differentiate respect to y, this mean my y going to plus with h. Okay, if I have here f as y z and here also as y z. Okay, here also as y z. Okay, but now I want to differentiate respect to z. This means my z going to plus with h. Okay, I just plus with h with something that I respect to. If I respect to z, this means I need to plus with to the z. If I respect to y, this means y plus h. If I respect to s, this means s plus h. So now the first question, I need to respect to s. Okay, let's say I want to respect to s. So my fs, I need to respect to s as y. So limit h approaching 0. Okay, f s. I respect to s, this means s plus h. Y over here minus f s y over h. So what I'm going to do after that, I'm going to sub this h inside my equation. I just sub that h inside my equation. Okay, so limit, I have here limit. Okay, I just write here limit h approaching 0. So what I have here 2 and then s plus h cube and then y square. Okay, this y square and 2 I put it together. Okay, and then plus y plus 4s plus h minus with this one, minus with the function of which is this one. So it's 2s cube y square minus 2y minus 4s over here. So then over with h, obviously over with h. So what we're going to do after that, we're going to expand it. Okay, so you're going to be 4s plus with 4h. Okay, so what we're going to do after that, we're going to cancel it out. Okay, going to cancel it. Okay, let's see what you can cancel. Okay, you can cancel this y and then you can cancel this s. Okay, you can cancel that s, okay, which will make your life become easier, make the equation become shorter. Okay, you're going to be disappear. Okay, so you only have here 4h minus 2x cubed y squared. Okay, so your equation only left this long. So what are you going to do after that? You're going to expand it, okay? You're going to expand it. It's quite good to expand it, but you need to expand it, okay? You have no choice, okay? So here you have square. Oh wow, you have square over here. So what are you going to do? This 2y square and 2y square, you can just factorize it together. And then you put your s plus h cubed minus s cubed over here. Okay, and then plus with 4h over h. So you need to expand it over here. Okay, just expand it. Okay, so s squared plus 2hs plus h square s plus h minus. Okay, what am I doing right now? What I'm doing is actually I just expand the cube over here. Okay, don't scale of that. Okay, so what I need to do after that, I just need to times with the inner part. I still need to expand it. So I'm going to write here. It's going to be quite long. Okay, going to be quite long. So y over here and then s cubed, and then going to be hs squared 2hs 2hs squared 2h square x, and then going to be h square s, and going to be h cubed minus s square s cubed close 4h. Oh wow, 4h. Okay, going to be h over here also. Okay, and then over h. Okay, then you see what you can cancel over here. You can cancel s cubed with s cubed. Then what some more you can cancel? You can cancel what? Okay, only that. Okay, only that you can cancel. Okay, only this one, also this one. So you're not going to have this one. Okay, you only have this fella. So what you're going to do is you don't need to expand it. Okay, you just straight away divide with h. Instead you expand it. Okay, you just need to divide with h straight away. Okay, you don't need to expand it. Okay, so now you have your 2y squared over here. So you're going to divide with the h inside here. Okay, you're going to divide h inside here. So h divided with h, going to get s squared. H divided with h, going to get 2s squared. H divided with h, going to get 2hs. H divided by h, going to get h squared, hs as well. So h squared. So hs going to be 3hs. 3hs is going to be cubed. Oh wow, here going to be square. And then 4 divided by h going to be here, gap bracket here, going to be 4. Okay, so now we don't have h already. So once we don't have h, so what we're going to do is just sub this h equal to 0 inside here. When you sub this h equal to 0, your h going to be disappear, going to be 0. So now you have a 2y squared, and then here going to have s squared. Then here going to have s squared again. Wow, okay, so you're going to have 3s squared. Okay, so you're going to have plus 4 over here. So you're going to have 6s squared y squared plus 4. Okay, so you're going to get that one only. Okay, if you see over here is logic. Okay, it's logic. Okay, so basically f as y, okay, you differentiate by using f as what you differentiate, by the way, is like this. Okay, when you differentiate respect to s, okay, when you differentiate respect to s, you differentiate s, but your y and z, okay, for the rest, I mean, not for y and z only, okay, for a, b, c, if you have 100 letter also going to be the rest, going to be constant. If you have as y, fy with respect to y, Let's say you want to differentiate y, your s and z are going to be constant. Okay, if you want to differentiate your fz, means you differentiate your z, your s and y going to be constant. Okay, is it okay? So when you want to differentiate something, this means your for the rate going to be constant. Okay, let's say for the first question, f as y to, okay, I don't want to have this one yet. Okay, to y plus 4x. So when I want to differentiate for fx, okay, just now I differentiate respect to x. Okay, I differentiate fx respect to x. So now I want to differentiate respect to x, isn't it? So I'm just going to differentiate it. So my 2 and y going to be a constant. My y going to be constant, so it's going to be 2y squared. Y going to be constant, so I just differentiate my x cubed. Going to be x squared, 3x squared. So my 2y, y going to be constant, going to be 0. My 4x, differentiate 4x, going to be 4. Okay. So here going to be plus a 4, 2, 3, going to be 6. Okay, then I just rearrange it. Did I need to rearrange it? Okay, I rearrange it. Plus 4. Then you're going to get the same thing too. Okay, so now let's move on to our second question. So now our second question, which is this fella, okay, which is f as y z 2x squared ln yz plus 1. It looks complicated but not, okay? So what you need to do is, you need to respect to y, okay, we have three questions over here, respect to y, yz and sz. Okay, so fy, when to respect to fy, so what you're going to get, when you want to respect to y, you just differentiate y, but the rest is going to be a constant. This means your 2s squared going to be a constant, so you just copy it back. Okay, you want to differentiate your y. When you differentiate your ln, I did teach y'all in the ln function video. Okay, I did teach y'all how to differentiate it. You're going to be, okay, the inner part going to be denominator, and then differentiate your inner part. Okay, so now your z is a constant, so we're going to have z only. Okay, so your fy is 2s squared z over yz plus 1. Okay, so for our fyz, so what we're going to do after fy, then you want to differentiate for z. So now your z you have for your numerator and also denominator. So what you're going to do is you're going to use product rule. I did teach out in the differentiation product rule. Okay, your 2s right now become your constant. Here going to be uv, so we're going to use formula uv. Okay, so here 2 square z. So here going to be y. Okay, differentiate this one, going to be y only. Okay, so plus yz plus 1 times with here differentiate your 2s squared z. Your 2s squared is your constant, your z is your variable, so we're going to have 2s squared only. Okay, so you just rearrange it. Okay, you have 2 square s over here, you have 2 square s over here, just factorize it. What you're going to have is yz plus zy. Okay, yz here, yz over here, so yz 2yz plus 1. Okay, so now your x and z. Your x and z is just the same thing. Okay, when you want to differentiate your x, your y and z are going to be a constant. Okay, so x over here. Okay, so now your x is not a constant, your y and z is a constant. So what you're going to do, you want to differentiate it. So differentiate x squared going to be okay 2x. Okay, so 2 to 4. Okay, 4x over here. So here is your constant. So what you're going to do is just copy it back. Okay, copy it back because it times. Okay. Okay, so after that is x again. Fx. Okay, from here differentiate x again. Okay, differentiate x going to be 4 only, so going to be yz plus 1. Okay, since all this is the constant, okay, if I want to differentiate f as also I'm going to get 0. Okay, but now your question you want z, so you need to differentiate z. So your 4 going to be constant, your y going to be constant. So now differentiate ln going to be your inner part going to be your denominator, and then going to be y over here. Okay, so your last answer is going to be 4y. Yeah. So we move on to our last question over here. So for our last question, which is f equals to fyz. Okay. S cubed plus 4s z square y e power z y. Okay, so now our question is f as y and also s z y s. So what are you going to do? Going to find one by one. Okay, you need to find your fs first. Okay, you need to find your fs first. So when you find your fs, you want to differentiate refer to s, just differentiate your s only. Your y and z are going to be a constant. So here going to be 3 square. Here going to be your 4 and z going to be constant. So you just copy it back. Z square. So differentiate s going to be 1. Okay, so you don't need to write it. So you go here is your constant. Here y is a constant, z is a constant, y equals to constant, e also constant, so it's going to be 0. So you don't need to write it. Then after that, y over here. So you need to differentiate with respect to y. When you differentiate with respect to y, differentiate y, s and z going to be a constant. When you differentiate a constant over here, going to be 0. Okay, so now our last question, which is f z y s. Okay, to differentiate to f z y s. So, and we want to differentiate f z. Do f z first. Okay, so your s and y are going to be a constant. So here constant, here is a constant. Okay, so differentiate s going to be 0. So 4 and s going to be your constant. So you just copy it back. F s. Differentiate z square going to be 2z. Okay, which is here going to get it as z. Okay, and then y is your constant, just copy it back. Differentiate e, going to get the same thing. Then differentiate your power. Okay, here going to get y. Okay, differentiate y z, differentiate z y going to be y. Okay, so after that you're going to do z y. So you're going to respect to y after that. So now when you want to differentiate y, your s and z are going to be a constant. So here is your constant, so going to be 0. Here you want to differentiate, and also here. Okay, here y square. Okay, so now you have 2 over here, 1, 2. So what are you going to do? You're going to use product rule. Okay, once again I did mention in the differentiation video. So here going to use product rule, which is going to get y here going to be z over here, and then plus with the 2y. Okay, so now you just rearrange it. Okay, just rearrange it, going to be 2yz. Okay, you have ezzy, do the same over here. You just factorize it. Okay, z y square plus with the 2y. Okay, that's the last answer. Oh, it's not the last answer. You need to find zys. Okay, so zys. So what you're going to do is, when you want to refer to x, your y and z are going to be a constant. So here, constant. So the last answer is going to be 0. So yeah, that's all for the partial fraction, partial derivative, and I hope it's going to be useful for you all. And before that, I'm going to teach you. Okay, So if we have as okay like this, or we have the cube, we have dy ds. So for the f, how are we going to start? We're going to start from left. Okay, we're going to start from left. For d, we're going to start from right. Okay, we're going to start from right to left. Okay, for the f, we're going to start from left to right. Okay, and I hope it's going to be useful for y'all, and see you guys in the next video. Bye bye.